You know, some of the most important research happening today isn't just stuck in a lab. It's actually being built into the world all around us. In this explainer, we're going to look at the work of a researcher who is literally turning complex code into concrete infrastructure, bridging that gap between amazing theories and the real world we all live in.
So first up, let's talk about the absolute foundation of our modern world, connectivity. We're talking 5G, 6G, and whatever comes next. The kinds of networks you need for everything from self-driving cars to remote surgery. But the real question is, how do you make them not just blazing fast, but totally reliable?
Now, let's think bigger. What about keeping an eye on our most critical systems? Things like oil fields or power grids, especially when they're in places that are remote, dangerous, or just extreme. How do you know something's about to fail before it's too late?
And finally, here's the question that ties everything together. Once you've built this massive, intelligent, interconnected web of critical systems, how in the world do you protect it? How do you build a shield strong enough for the threats we face today and whatever is coming tomorrow?
See, the thing is, these aren't separate problems. They're all deeply connected. And it turns out the work of one researcher, Mustafa Sadiq Aljumaily, gives us a fascinating roadmap for tackling all three of these challenges head-on. Everything, and I mean everything, starts with the network. Before you can even dream of a smart city or a factory that runs itself, you've got to have that digital highway for all the data to travel on. This is the bedrock.
A huge part of making 5G and 6G work is something called M-wave beamforming. Now, instead of thinking of a wireless signal like a light bulb, just spraying light everywhere, think of it more like a spotlight or even a laser pointer. It focuses a powerful, concentrated beam of data directly where it needs to go. The result? A massive boost in speed and way less interference.
So how does Dr. Aljumaily put this into practice? Well, his research breaks it down into a really clear process. First, you have to analyze how lots of different people are using the network at the same time. Then, you apply some really sophisticated algorithms to manage all those signals efficiently. And the payoff is huge. You get higher throughput, meaning more data gets through, and much, much greater reliability. It's a key shift from just raw power to really intelligent control.
All right, so once you have that super solid network, that's when the real fun begins. You can start making things smart. This is where all that data zipping along the digital highway actually gets put to work, especially in some really tough industrial environments.
Here's a perfect real-world example from his research. Imagine an oil field. You've got countless sensors out there. That's the Internet of Things, or IoT. They're collecting tons of data. By applying advanced AI, specifically a type of deep learning that's great at understanding patterns over time, the system can do more than just monitor what's happening. It can actually predict faults before they happen. That is a complete game changer for safety and efficiency.
And really, that's the ultimate goal here. It's not about just collecting mountains of data for the sake of it. It's about transforming that raw, messy data into a powerful tool for prediction. It's about giving industries the power to see what's coming and actually do something about it.
Okay, so we've got the network, we've got the intelligence. The next logical and frankly absolutely critical step is protection. How do we build the shield for this new digital world?
A huge part of his work is about a major shift in how we think about security. For decades, traditional security was like a castle, with a big wall and a moat. Once you were inside, you were trusted. Well, zero-trust architecture completely throws that idea out. It assumes no one is trusted by default. Every single user and every single device has to be verified every single time they try to access anything. And his contributions in this space are broad. We're talking about designing practical zero-trust models that actual organizations can use, developing specific security protocols for the industrial Internet of Things, and even researching next-generation quantum-resistant cryptography to defend against the kinds of threats that don't even properly exist yet.
And this is where it all comes together. The super-fast networks, the predictive AI, and the rock-solid security. They aren't separate fields of study. They are the essential ingredients for building the incredibly complex systems of tomorrow, like our smart cities.
And you can see right here how a true smart city isn't about just one technology. It relies on the seamless integration of next-gen communications, intelligent IoT frameworks, and foundational cybersecurity. Dr. Aljumaily's research operates right at that critical intersection where all these things meet.
One of the most exciting applications that comes out of this is the concept of digital twins. Basically, it means creating a perfect, real-time virtual model of a physical object.
like a bridge, a power plant, or maybe even an entire city block. This lets you simulate stresses, monitor its health, and optimize its performance safely in the digital world. So what's the tangible impact of all this work? Well, let's look at some of the numbers that really show how this research is making the jump from academic papers to real-world influence. The foundation of his impact starts with pure academic rigor, and that's demonstrated in over 60 peer-reviewed publications.
But it definitely doesn't stop there. That knowledge has reached an incredibly wide audience, with his research being read over 202,000 times by people in both science and industry.
And maybe most importantly, that work is being built upon. It's serving as a foundation for new innovation, and you can see that in the nearly 205 citations from other researchers all around the globe.
This quote really gets to the heart of his entire approach. The crucial point is bridging theoretical rigor with immediate industrial application. In other words, this is not just theory for theory's sake. It's about developing academically sound solutions that can be and are applied to solve urgent, practical problems right now.
And that leaves us with a fascinating question for the future, doesn't it? As these technologies of connectivity, intelligence, and security continue to merge and evolve, what's the next piece of our world that will be fundamentally transformed by this kind of research? That's something to think about.